Yo, what's up, everybody? Welcome back. Today we're working on writing an async HTTP server in Zig based around epoll. And the reason is we are working on this project where we are simulating on a server a bunch of like balls moving around, right? We won't get too far into the details here, but we'll just say that we have a web browser who's doing HTTP requests at 60 frames per second, which will ignore the absurdity and stupidity of that comment, right? But we are polling 60 frames per second to get the state of a chamber at a given point in time. And that's going through this HTTP server that we just set up, like doing whatever like Zig's HTTP server API would like guide us into doing, right? And so the way that it is set up is they have an HTTP server who takes in like a single TCP connection. And so our like main loop basically just says like, okay, I guess we have like a TCP server, and we'll wait for some connection, and when we get that connection, then we will spin up an HTTP server around it, handle the request, and then move on with our lives. Now the obvious major flaw with this is if we can only handle like one request at a time, and even worse, if that request just drops for whatever reason, we just get like stalled out from everything. So if I like go in here and I look at this test Zig function I wrote, right, where all we do is we just open up a TCP connection to ourselves and do nothing with it, right? If we run this, so Zig run test Zig, we see that this should immediately stop as soon as that starts running. And then we like kill this, and then this starts again. This is like brain dead, absolutely stupid, right? And so what we want to do is we want to have some way of servicing more than one request at a time. Now, if we were to do like the simplest thing that still kind of conforms to the way like Zig's API is set up, we would probably end up spawning one thread per connection, right? The reason for that is if you look into like the details of what this guy's doing, you give him a TCP connection. If you're like, hey, could you like wait? I would like to wait for you to give me some like a full HTTP header. There's like a while true in here that reads from the socket, which is fine. But what if we wanted to service multiple connections on one thread? Like, really, it's like a little silly. There's too much overhead. Well, I shouldn't say too much. There is what I would consider an unreasonable amount of overhead to spawning a thread per TCP connection. In reality, nobody is ever gonna fucking use this website, and so this is never gonna matter. But like the perfectionist in me thinks that it would be better if we could handle all these things on one thread. And so we've kind of started building up this idea of an event loop, who is based around epoll. Epoll is Linux's mechanism. Linux ends in an S, and so I got a little confused there. It's Linux's mechanism. It doesn't sound right. But it's the mechanism in Linux that allows you to basically say, hey, I've got like 100 file descriptors. Could you please tell me when there's data ready on them, and like tell me which ones? And so the way it works is we basically like spin up a epoll file descriptor. We say, hey, somebody is going to tell us that they have some handler object that they are going to use for this file descriptor. And so this handler object is very simple, right? It's just a data pointer and a callback, as well as like a dinit function, which is going to be used sometimes, but that's not too important, right? We take this handler and we just like drop it into a vector. We have to be careful because the location of this thing has to be like kind of stable. So we put it into a vector, and make sure. Sorry, in this language it's called array list, but vector. And we give it like a constant offset into that thing. We give that number to epoll. And so we say, hey, epoll, we just got this thing. We got the callback. We put it at like position 4. So when you see any data on this, like any data transmission on the socket, can you just like give me the number 4 back? And then we like look up number 4. We call whatever callback is in there, and depending on like the output of that callback, we might decide to like, hey, it's time to like remove that thing, or it's time to shut down our whole server, whatever. Which is pretty straightforward. There are some like limitations that we've kind of like baked in here, where we register one handler per socket, and if anybody else tries to register a second one, we just deny it. This is a little different than what was on stream yesterday. I realized post stream that it makes more sense to just have reading and writing from the same socket be handled by the same state machine. That just like cleans up a bunch of stuff. And so we have an example of a little echo server here in TCP. So I think it's echo Zig build, and is it not in my hello Zig build? Here we go. Event loop test. So if we run this guy, we should be able to telnet into ourselves, except that we don't have telnet installed. So we'll just yoinkies him really quick. Give him a sec. He's got to think. He's got to reach out to the internet. He's going to be like, hey, internet, could you please tell me where to get this telnet thing from? And if I just type like some stuff in there, uh-oh. Uh-oh. Oh, it's because I'm running the same fucking server 2 times at once. That's really bad. On the same port, so it doesn't actually know which one I'm trying to talk to. Let's try it again. Telnet? Hello? Right, so I type some stuff, it sends it back. Great. And if we spawn 2 connections to this guy, fuck. Got Telnet again? Give him a sec. Even though we clearly have Telnet on our disk, he's got to be, he's going to take something too. If we open 2 at once, he's managing 2 at once. So the idea of, wow, I thought I almost typed the exact same thing there when I spun the keyboard. So we have like an event loop that works. And so today's task is taking this event loop that can like do asynchronous TCP and build a HTTP server around it, right? So we can probably reuse a bunch of the stuff that Zig has like in its standard library under the hood. But we're gonna have to kind of deal with like the transmission and receiving of data by ourselves. That is the plan for the day. That's the plan for the day. Yeah, all right. Some messages in chat. Think can't be using your brain. That's a nerd program. Unbelievable. Yeah, I agree. No thinking here. We are very clear about that all the time. You got a haircut? Yeah, so I took my dog to the groomers because she hadn't been groomed for a while, and I cut my hair in solidarity. Because, it would be rude to let her do it by herself. How long do I tell it to configuration? Probably never. I will probably just keep putting up with this pain for the rest of my life. And that's just going to be the way it is. Okay, so let's create this concept of an HTTP server. Initially, I was kind of considering the idea of in Rustland, in dog groomer 2 for the price of 1. Yeah. They just take the clippers and they go I put my head next to the dog and they just take the clippers and they go over one and just straight onto the next. So I was going to build. Originally, I was thinking I was going to build this similar to how a Rust TCP socket abstraction would work. So they have their engine, right? Which is similar to our event loop, and you create a TCP stream that works on this engine, and you can then build on top of this TCP stream an HTTP server, right? And so in your HTTP server, you would be await TCP stream dot read, and then you would get some data and move on with your life. I'm thinking now that the way that this is set up, that doesn't really work the same way. I mean, what really makes more sense is we could have a TCP read write struct that lives inside our HTTP server, but really the HTTP server is the owner of the connection, and so the HTTP server is the one who's registering himself with the event loop, right? So I think that we'll just kind of consider this on an event handler or whatever the hell we want to call it, and we just have to kind of stub out what that requires. So he's gonna have surely he's gonna have a TCP stream inside of him. So this is gonna be a stud net stream. And is that it? I guess he's gonna have, if we're just stubbing this out, I guess that is what it's gonna look like. And he's probably gonna have two states, right? He's gonna start by reading some data, and once he is read some data, he's gonna try to respond to it in some way, right? And if somebody is reusing their HTTP or their TCP connection for more than one request, we don't really care about any of the second half of the request until we're done with the first half, right? So maybe we're gonna have this have some sort of state, and we'll have state is equal to some enum, and now right for now, we'll just say that he has a read state. This isn't a union, this is a enum, so we'll just have read and write. I think my language server just died. Classic. Okay, sure. And so then we're gonna have some sort of whole function. If we're gonna reuse the Rust terminology. Something's broken here. I'm just gonna quit and restart this. And he is going to do some stuff, and then maybe he's gonna error out, and he's gonna return some sort of action that he would like the parent, the event loop, to do with this once he's done. LSP died, Zig stream confirmed. I mean, to be fair, my Rust LSP dies all the time as well. I think that in every language my LSP dies all the time. I don't know what I'm doing something wrong. In this one, it's particularly bad because I'm using ZLS 012 with a Zig 013, so I think there's probably some constraints that it's expecting to be held up that just aren't. But that's okay. And then we're gonna have some sort of like way to get an event handler out of this guy. So this is going to be like in the same way that in Zig you have like your general purpose allocator and you call the allocator function on it to get like the generic interface. We're going to like copy that pattern here. So he's going to have self is an HTTP server. And yeah, okay, that's fine. And what are we going to do here? We're going to, in our handler, we're going to return some sort of event handler who's got a callback as well as some data. And we're gonna have to like make this callback. What we've been doing in these other cases is we've been kind of like making our member function conform to like the API of the event loop, where it says like, hey, I'm gonna take in any opaque user data so that I can like cast it to myself and whatever. But I kind of wanted to try this time doing something else where we write this as if it's just like a normal member function. But then we wrap it here. So we can say const callback is equal to some structure that's going to have some function f on it, and this function is what's going to follow this API. Fuck. What did I just do? What the fuck? I think I just accidentally deleted something, but that's okay. So here we'll call this f. Const callback is equal to struct. This function goes in here, and then we pull out the function that we made. This is how you do like inline functions in this language, by the way. There's no like support for directly putting a function in line like this, but if you can put a struct inside, and structs can have functions, so you might as well just do this. And then we'll just kind of wrap it. So we'll just say const handler or server s server is a HTTP server pointer who is equal to a pointer cast and a line cast of user data. And then we can just call server. Oh, that's so elegant. I mean, I'm not against it. I kind of like this is like a little silly, but there's a kind of pattern that I like. I want to say discovered, but that makes it sound like I'm the first person to do it. I just mean like I happened upon it at some point, where if you're trying to do like if you want like in C, you could do this thing where you have like static x is equal to 4, right? Int x equal to 4. And what this would do is in the scope of this function, you have like a global variable that isn't accessible from anywhere else, but you like it is global, and it will like if you do like x plus equals 1 every time this function is called x will increment, right? Zig doesn't have that, but because of this fact that you can put structs in here, you can do something like this where you can say like const globals is a struct, and in here there is a variable x which is an int that is equal to 4 or i32. And then in here, you can call globals.x plus equals 1. And this does the same fucking thing. And it's because like they didn't do any extra handling for this like special concept. It's just because we can put structs wherever we want, we get a lot of interesting behavior for free because of that, which is kind of fun. So, you know, this is like a little silly, but the fact that you just have like generic struct do whatever you want is like kind of nice. I'm not actually opposed to it. Okay. So I think that for now what we're going to do is we are just going to say we're going to do nothing, and this like none action, I believe is what I called it, is the one that says like, okay, just call us again when we have more data. How hot is it where you live? You're always wearing jumpers? Well, it's just because I like find them way more comfy. It's like wearing a blanket all the time. So, you know, it's in my apartment's facing north, and I'm very far north, and so or not very far, but like I'm you know Pacific Northwest, and so it actually doesn't get that hot in my apartment, which is kind of nice. Also, until recently, I was using the hoodie as like a proxy for feeling how hot my dog might be, right? Because she had like a lot of fur, and I was worried that like she would get too hot. So I was like, if I feel the same pain when I go outside, then I'll know when it's time to turn around. It's the same reason why I don't wear a rain jacket when it's raining. It's just fucking stupid, but anyways. Okay. So, depending on his state, I guess, he is going to do different behaviors. So I guess we'll have function read. And I guess it's gonna be like a void function for now. This is probably gonna be an erroring void function. And we'll have a write. Yeah. And actually, let's take a pause here. We'll finish this section here. We'll say if we're in our read state, we'll call self read. If we're in our write state, we'll call self write. But I don't want to get too far down this road until we actually compile something and make sure that we aren't doing anything like brain dead stupid. So maybe, how is this going to work? We're going to like register like a TCP listener on the event loop, which we kind of have here. And just every time the TCP listener gets a new connection, he's going to create an HTTP server out of this guy. So before we were just making this echo error, and we can just say const HTTP server is equal to HTTP server init. Did we give him an init function? No, we did not. So we're going to init this guy with some stream. And he's going to return himself. And I think we're actually going to return a pointer to ourselves, because as soon as this function ends, like this is like a short-lived function that's called on the event loop. If we try to register our handler here with a pointer to ourselves, it's going to point to like this thing on the stack. This thing on the stack is going to go away, and the event loop will like then start like just accessing invalid memory when it tries to call us. So if we instead say, okay, we'll heap allocate ourselves and destroy ourselves, then we're chilling. Then we can say that it's up to the event loop to kill us when it needs to kill us. So here we're going to take in self HTTP server, and this is going to return void, and we're going to say self alloc destroy self, and then here we're going to have to store the allocator, and then here we're going to take in the allocator, and then here we're going to say var or const ret is equal to a new allocation of our self. Then we say if something else fails, fuck off. So alloc free ret, boom. Then what happens? We are going to have to set the TCP stream in like non-blocking mode. So try set non-block of TCP. And then I guess we'll have to return a thing. So ret is equal to something where we have TCP is equal to TCP, alloc is equal to alloc, and state is equal to read. Return ret. And now over here, we can call init with our allocator and our connection. This is failable, so we have to write try here, and we have to do this same thing where we close the connection, otherwise, which also kind of indicates we have to close the connection in our HTTP server as well, actually. So where the fuck is that? HTTP server, dnet, self, stream, self, TCP, close. There we go. Does connection have... Yeah, it's fine, it's fine. This is fine. Okay. So we have the same behavior, though, where if this fails to initialize, because afterwards we would normally go error defer HTTP server dinit, right? Now the problem here is that this dinit function is going to close the connection. And if we were to write here error defer connection close, there'd be like two places trying to close it on the success case. So we instead have to do this like unfortunate manual error handling where we say if we fail to make this thing, we're explicitly going to close the stream. Otherwise, the dinit function of our function will do it, or of our dinit will do it. And then we just say HTTP server handler, and everything's happy. So let's take a quick Zig build here. Expected error union type found something else, so this is at 93. Hello, am I in the wrong function? Our file, I am. 93, so... Oh, it's because I wrote try and catch. I can only try or catch, one of the two. Here, when we create our handler, we have to say, on dinit, we would like you to call our dinit function. So we have to provide one, and since we are considering ourselves owned by the event loop, then we do have to provide this. And so our dinit function takes user data and returns void, and we will call self dinit in this case. Server dinit like this. And we'll call this opaque dinit to avoid aliasing of names. Expected pointer slice array found a pointer at 81. Error union is ignored. What error union? Oh, here. And then this is mad at like 32. So what's it mad at? Expected pointer slice array or vector type found event loop handler. Oh, oops, this is destroy. Classic. Single element and multi-element are different in this language. Okay, so we compiled. And maybe we can, at the very least, just in here, just say HTTP server pulled. And this will at least give us an indication that we're on the right track of making something that is usable. So event loop test. And so if we just like curl localhost 8000, we do get a pull, and we do it again. We are seeing like some indication of something happening. So that's a good sign. A good sign. Okay. So now we actually have to do something. So let's say, let's look at the Zig HTTP server implementation, and we can kind of like get a feel for what we can reuse and what we can't reuse. So we can look at like receive head, which is like the first function we would normally call. And so what does he do? He has some internal state stuff. He has this like head parser, and if the read buffer length is greater than 0, we do this thing. Otherwise, we do this loop where we continue feeding this thing. I don't really understand what this first block is for. If read buffer len is greater than 0, they do assume that it's finished immediately. Oh no, that's only if it's finished. So they do one. Oh, I see. Maybe they're doing like a first iteration and then other iterations for some reason. But overall, it looks like they're just kind of saying, we'll feed this header parser. And if the state is finished, then we will figure out where that is and probably generate a request head thing. So this is a request object. I think that we'll probably skip using this because, well, okay, so there's the head. The header in here has a bunch of stuff that we do care about. So we can probably reuse this. What is like on this request? If I remember correctly, it has like the point of the request is that you can like shove a response into it. And the response is probably in the same state where it's kind of assuming, yeah, it's assuming a synchronous write. So we'll have to replace this as well. So I think probably what makes sense is we'll use the header parser to figure out, I think that this header parser figures out where the end of the header is. Returns number of bytes consumed by headers. This is always less than or equal to bytes len. If the amount returned is less than bytes len, the parser is in a content state, and the first byte of the content is loaded at bytes result. I see. Yeah, makes sense. Yeah, seems fine. So I guess we'll like make a header parser and we will feed it in the same way that they feed it. So we'll say header parser. I wonder if it makes sense for our state to be like tied to if we're in read mode or write mode. Like we could make this like a union enum, right? And then like stick a header parser here. But I think for now we'll do it outside and we'll see if it like makes sense that this like if there's like truly bimodal like state that we need to deal with, if that makes sense. So we'll call this header parser is std HTTP header parser like this. And I think this is a type. Yep. And do we need to construct this guy in any way, shape, or form? No, it seems like we can just say this is equal to this on init. Just take a default. I guess maybe we should kind of use this pattern more often anyways, where we kind of like set defaults here and we just use our init function to set stuff that can't be known at compile time. Okay, so we have our header parser. And when we are reading, we just feed this thing. So we say self HP feed while true, we try to feed the parser. So we'll say so we read from the connection. We have to read into some buffer, so var buff. We actually need probably this buffer to exist long term, because we're gonna have to actually like look at the data that we've read out. So maybe for now, we'll say that we have a buff is a std array list, unmanaged, I guess, of U8s. And we will like read into this thing as we can. So this also can just equal this. So we can say like, I guess we'll maybe like stack allocate a buffer here. How do we want to do this? How do we want to do this? Yeah, we'll say we have some buffer, which is, 1024 U8s. And we will try to read into this buffer. If we get an error, and the error is would block, we're fucking chilling. We're just like back the fuck out. But if it is not would block, if E is equal to error would block, otherwise we need to do something else, which is just return the error, right? Any other error is a problem, but would block it we just like expect to happen. And then we just say const buff len is equal to this. This needs to be turned into a slice. And then we can feed this with the buffer. And I guess what does this return? This returns the number of bytes consumed by headers. This is always less than or equal to bytes len. If it's less than bytes len, the parser is in content state. Okay, so here we would say something like, header size is a U size that starts at 0. And here we'll just say self header size plus equals to this. And then I think that when I saw usage of this thing in the HTTP server, I think that they checked for if self HP state is equal to finished, then we consider ourselves done. So we can say self self state is equal to write. I guess maybe calling it write is a little bit wrong. Maybe we'll call this read header and write. And later, if we actually have any need to read the body, we should do that. Although I guess even if we don't read the body, like we don't process any content from an HTTP body, we still have to like consume it in some way. So I wonder how they manage that. But it does seem like at the very least, read header and read body are like different states. Is this how I'm supposed to do enums in this language? I think it is. I think the case, the style for enums, I'm pretty sure is underscores. Okay. So we'll rename this function read header, and then over here we should have read header, and this is read header, and read body is right now just unreachable because we don't know what to do. We don't know what to do yet. We forgot that we also have to append this data to the header. So we'll say self buff dot append slice with our allocator. What do you think about Zig structs not being packed by default? I don't think they should be packed by default. Like, packing by default would be an insane decision, right? Because if you have like const my struct is equal struct like packed struct, u1, a is a u1, b is a u2, and c is a u32. Like this, accessing these things is like very expensive, right? Because how this ends up getting laid out in memory is that you have like 2 bytes. You have like I'm not sure if it's like forwards or backwards. We're gonna assume that it's forwards for now because I don't want to like think about it. But we would have like A, B, part of C in this byte. And then we would have, we'd have, can I do like an L here maybe? Yeah. Then we would have like the rest of C here, right? And so like if you actually wanted to like use this thing, say you wanted to just do like C plus equals 1, right? You would have to like read both of these 2 bytes, extract the part of C that is in the first byte, and shift it to the and then or in the part of C that is in the second byte. Maybe do some shifting on that side, depending on if it's like what the bit order is in the field. And it's like, for what? Like why? Like to save a couple bytes or a couple bits, right? So packing by default results in just like all of your code being slower. So like I think that the decision to not pack by default is like the most reasonable, right? In this world, this ends up being 3 bytes instead of 2. Or sorry, this is actually sorry. This would be 1, 2, 3, 4, 5 bytes. 4 for the U32, and then 1 for like the rest of the U32 and the AB. If you didn't pack this, this would be 6 bytes. You'd get 1 extra byte for like way more efficient access. So I think packing would be a massive mistake. Massive. Okay, so we are going to try to append to this our buffer with the buffer. So we read some out and we only append from 0 to buff1. And then at the end of all of this, I guess this goes into the state read body, not write. And here we also, this would block is like the exit condition here. So I think maybe we're good. And then maybe for now, when we get to read body, I guess maybe we should also stash the header somewhere. So we'll say header is some sort of like std HTTP header, which starts as null. And when we finish reading, we should parse the header. So I think it's std HTTP header. No, it's head, sorry. Is it? What is it? Head? Server? Request? Head? There we go, found it. I found it. And so this guy has a parse function. And we can parse in self.buff items. Which means that this header has to be whatever the fuck that was. Server request head. Do you know how much is going to be a host per hour? Or how much it's going to cost? 1 client connected for an hour is a lot of requests. Well, theoretically, so I rented this server for like $2 a month. And according to what I signed up for, I have unmetered connection. So surely that's not true, right? But they don't charge me per request, right? So like whether or not the server will live, right? They might go, what the fuck, you're eating so much bandwidth. Fuck you, we're gonna shut down your server. That's like a very real possibility because I'm only paying them $2 a fucking month. Dude, it's crazy that you can get like a full-on computer for $2 a month, and it's not even that slow. It's got like 3 gigs of RAM, it's got 1 vCPU, or maybe more, let's see. Hold on, do I have my SSH keys up here? No. Hold on. I can get in. One second. 1 second. Let's just see. So, top. Yeah, so we only have 1 CPU, which is fine, but we have 3 gigs of RAM, and it's not that slow. It's not that slow. So, like, it's $2 a month. Isn't that fucking crazy? That seems insane to me. And I could just get a machine that I could like just rail that CPU for forever, and they wouldn't charge me anymore. Like that's so sick. LS CPU. I close the window 1 sec. Yeah. So 64-bit. It's got some stuff on it. I mean, my test was that I compiled Ball Machine. I think it's sorry. I have Zig Linux zig build. There we go. And let's see how slow this really is. Like, it's not fast, right? This isn't like, I wouldn't want to do development on this, but I expected that I wouldn't even fucking be able to build this thing. I expected that I was gonna have to like build, like basically build on my machine and like upload the binary. I was expecting to have to do like a ton of extra work. But it's like fine, right? That's not that bad. So we'll see. What cloud provider? I actually don't even know. I just went to low end boxes and typed like cheap. I just typed in like cheap computer on low end box, and I just read through. I think I went to low end box, and I looked at somewhere there was like a list for like 2023 hosting offers. There was some link here that was just like the best of 2023 or something, and I just clicked on that. So I don't know what the fuck I'm doing, but it's pretty crazy. It's pretty sick. Anyways, let's get back to this HTTP server shit. So anyways, back to that question of like how much will it cost. I think that like the cost is fixed. Me and my dad co-located a 256 gig of RAM server we got a few years ago for like $1,000 from eBay a few years ago. It's crazy cheap compared to the cloud if you count the cost over the whole period. Yeah. That's true. Self-hosting is better. The reason that I didn't want to buy a box and shove it somewhere was because I didn't want you guys getting my IP, right? So because of the fact that I could go through a VPN, but I'd rather just like I don't even want you guys like on my network. I don't want like if you guys like break out of those WASM modules, I want like the damage that can do to be limited, right? So if you guys are just like completely like somewhere else, then I have to worry a lot less. Well, that's just rude. Well, I mean, come on, like I can't just assume you guys aren't gonna try to do something fucked, right? Like the assumption is that you are. There was at one of my jobs, we had like, this was back in the day before Slack was so big. We had internal chat HipChat, which was like Atlassian's chat program. And occasionally, right, somebody would type get good into the chat, like just to fuck with people. And somebody else would write like get is not a valid get command in response. Obviously, right? That's the obvious answer. And so I was like, wouldn't it be funny if I actually hooked up a get client to this, right? Keep in mind, this is at work, right? It's just work, right? Like you would expect that like this isn't a problem, but like immediately all of my coworkers started like trying to break into my computer through it. So they got like, immediate shell escape through Git, right? Obviously, if I just like hook Git up to a TCP client, obviously they're going to get into my machine, right? And it's like, it's just the natural course of things that if you expose your computer to people, they're gonna try to fuck with it, right? Like it's the only way. Yeah, then once we moved on to like Slack and stuff, then the IT kind of like they kind of clamped down a little harder, right? I think that you need to like sign up for like a dev account and get like dev keys and stuff, and it's like, oh, I have to like go through the company. I can't do that for my shitty little bots anymore, so I just stopped. But that was like the golden era for me. Just like we had so many stupid little bots in there. It was so fun. Okay. So I guess what we want to do is we want to see if the header reparse is like reasonable. So if we get here, and we say we have some header, I need to close this thing. And then I guess if we just curl this, it might do something. Fuck. 29. So this should be read header now. Yeah, I would totally try to break your shit, but then I would privately message you about it. Yeah, exactly. Exactly. And I would just rather that the scope of that is limited to, outside my house. And sure, I could like buy a box, put it into a port of my router that's like isolated from the rest of the network, and then VPN that. But I don't want to. That's just more work. Okay, so if I curl this now, oh fuck yes, dude. Hell yeah. That's so sick. And then on a second one, I can do it again. Curl localhost 8000. He failed to connect though. Oh, because this crashed. So I did get the second request, but then something got, oh, right. So we actually panic on unreachable if we get to the function body part. Which makes sense. But otherwise, it's like, it looks like we're doing the right thing here. So once we get the header, we need to like consume the body. And I don't actually know how to do that. What do they do? What do they do? So say that we call on this request, discard body. Here we go. So how do they do this? Preparer received another request on the same connection. There are two factors to consider. The body the client sent must be discarded. The server's read buffer may already have some bytes in it from whatever came after the head. This may be the next HTTP request or the request body. If the connection won't be kept alive, then none of this matters because the connection will be severed if the response is sent. Okay. But otherwise, if they receive the head, they call request reader, then they discard. Reads the stream until the end, ignoring all the data. So, but this is kind of assuming here's an idea. Design a QKD for your async HTTP server in Zig. Be different. I don't know what the fuck QKD is. Quantum key. No. Just no. So this discard, it's reading until the end of the reader, but doesn't that mean that, like, what if they have, like, the next request is buffered in the reader, right? Like, I'm kind of assuming that somebody's gonna be like, somebody who's using HTTP connection, pooled connection, they might go like, here's head, here's body, and here's like next head. Oh, but maybe this won't happen until I respond to the previous request. Maybe that's like kind of like enforced by spec. At the very least, they do this, so it's good enough for me. So I guess for now, we will make a read body, and we will just consume everything that we fucking can. Although, no, something about this doesn't feel right to me. Because, like, what if they just haven't sent it all yet? They might have sent, like, half the body, and so me saying that I consumed everything that I could up to the halfway through the body also doesn't sound right. So let's look at this again. Discard body. So they get a request reader, who is just a normal any reader, who has read. Okay, so his read function is read chunked or read content length. I see. And so if they gave me content length, I will read probably just until that content length is finished. And if they read chunked, there's probably some form of like HTTP like rules for that. So I guess what we'll just do is we will just assume that we can only process content length based ones. I think that's reasonable. It's reasonable. Sorry, I missed the first half. Did anything major happen so far? We got a little, we got an HTTP header out of our async stuff. Does it handle HTTP pipelining? HTTP pipelining. Let's pretend I'm fucking stupid. Without waiting for the corresponding responses. So I guess no. If we do what I'm about to do, the answer is just straight up no. Well, how does this work? Is this like an extension that I have to like flag support for? Let's pretend. Yeah. We're pretending. We're pretending, okay? It's not real. Of course I actually do know what I'm doing. I'm just pretending for your guys' benefit. Requires both the client and the server to support it. So I guess I just won't. Right, I assume that probably in the first request, you have to say, you probably send back some header that says like pipelining is okay, and I just won't say that, and so it's not something you have to worry about. Okay. So I guess here, we can assume that self.header is set. And I guess we want to look at this header and try to figure out what the content length is, which should be here. So we look at self header content length. And we know, I guess, from here what our header size is. So we can just keep shoving the body into our buffer probably, and then kind of split it by here. So we'll say while buff self.buffer.items.len minus self header size is greater than or is less than content length. We'll just keep reading. So it's kind of like this same thing here. We read some, we check if we block, try pen slice. And I guess if we have made it to that point, then we should change state. So const required size or expected end size is going to be CL plus self header size. Should you trust the header's content length? No, but I think that the degenerate case here is that they get fucked, right? So if they lie, then if they lie it's too big, then we will just stop early and we'll just like have a connection sitting here. What we'll probably do is we'll maybe like kill connections that have been sitting here for too long. I think that there's probably some sort of like there might already be some sort of like Linux TCP keep alive thing that's going on there. So we might be able to get away with that. We might be able to get away with if they say the content length is too small, then if they say it's too big, then we'll hit the end of the stream early and we'll just like sit there forever, which is fine. And if they say it's the right size, then like if they say it's too small, then the next header will be corrupt and we'll like close the connection. So I don't really see any like major problems there. The only problem is that you could like DOS me, right? By basically like giving me content links that are too big over and over again and never finishing them. But as long as I just like clean up that case, okay, then I think it's fine. How do like other people handle this? How do I know when an HTTP body ends, and how do I protect against someone giving me an incorrect content length? Every time I've asked ChatGPT anything like this, he gives me like a fucking dumbass answer, but we'll see. Sometimes he does this right. Specifies the length of the body, determine the end of the body, just add the bytes after the header. Okay. For chunked, I don't give a shit. Protection against incorrect content length. If they don't match, okay, indicate something, sure, okay, but that doesn't really help me. Robust error handlings were just inconsistent or incorrect body lengths. Okay, yeah, see, like, this is the type of thing, every time I fucking ask ChatGPT, like, what are, like, some, like, common mitigation strategies? It's like, just look at the data and follow best practices. Shut the fuck up, ChatGPT. I want to know what, like, the actual, okay, so, yeah, that's fine. So, the other thing we'll just have to kill our connections if like every once in a while. Does the Linux kernel handle TCP keep alive? I guess they could be like sending keep alives and not sending data. So probably we're gonna have to like kill connections, but it's fine. It's fine. Okay. Okay. So now we can say, well, this is less than expected end size. Ask it to elaborate. Every time I go through this, I don't get a satisfactory answer, and it's usually because I like fall back on ChatGPT when I'm like struggling to Google something, and I really do like believe at this point that if I struggle to find something by Google, then like it also didn't have it as like a significant portion of its training data, and it will also struggle to find me an answer that I'm happy with. That's like at least my experience so far, but we'll see. You know, maybe I'm wrong. Okay, so now we can say if self buff items len is greater than or equal to. Oh, I was going to say if it's greater than the expected end size, we should like error the fuck out. So we'll say return error invalid data. If it's equal, it's time to change states. So self state is equal to something, right? And then what? Is that it? Maybe. Okay, and then well, let's just see what happens here if we do this. So this unreachable now turns into try self read body. And I guess we should also consider what do we want to happen if any of this shit fails, right? So like if we fail, we probably just like close the connection and say fuck you, right? Maybe we respond 404 as well. But we'll come back to that. We'll come back to that. So maybe we'll just say fix me 500 or 404 on failure. Plus close connection. That seems reasonable. That seems reasonable. And then also here, we probably also want to like set reasonable max length, right? Like we don't want people to just be able to give us like 10 gigs of data. We want to limit them to something that's like reasonably small. Yeah, okay. So let's start here. Let's just see what happens. This doesn't compile, so 100. This content length needs to also be like this. I guess here, if this is invalid, we can't handle it, so we'll just say if this is null, there's no content length provided, we will just return error unsupported. Probably not 404. Yeah, well, you know, I think that sometimes people intentionally return 404 for all errors just so that people can't like try to probe behavior based off of the return codes, right? Like if you look for resources and if you're just like scraping the whole website, you can like kind of deduce some amount of information if they give different error codes for different conditions. And sometimes you don't want that, but you're probably right. Okay, so this just did nothing. But I think that's pretty reasonable. We didn't crash at least. And maybe we should at least say std debug print write time, baby. I guess also, since that this poll function is only going to be called every time that there's like a change in socket state, we actually kind of want to do all of this in a loop. Right? Because if we like read some data and we've got all the data we need, then we should immediately write back. And because like otherwise there's the other side is just going to be like, hello, are you going to send me anything? And we'll be like, hello, we needed to wait for you to write something for us to send anything. So we should actually like immediately loop through the next state. And I guess what we should do is we should have some state that's finished, right? And so if we are finished, that's when we return dinit. Yeah. Yeah, I think that makes sense. And then it kind of maybe actually makes sense for us to just let wood blocks bubble up and then catch those at the top level. So maybe we'll say poll no error. Maybe like poll without, I don't know what to call this, right? What's the named difference between like I have this function that does the work, but then I have another function that does the work and then checks for error conditions. Safe poll, yeah. Safe poll, error handled poll, poll no error. I guess it's like kind of poll no error. I think it might be a mistake, by the way, for our poll interface for the event loop to return to accept error values. Because what it does when it sees an error is it just like, oh, there was an error, and then just like leaves it. And it's like, that's fucking stupid. Like, surely it should do something reasonable with that error, right? So I might come back to that, but. So this is going to return any error. I guess it will just return handler action. Oh, yeah. That actually feels good. So this will return this. This will return this. And when we construct our callback, we will just return this, and that's fine. And here he'll pull no error. Perfect. Perfect. So we're going to say self pull catch. Pull and pull and pull. That's not unreasonable, to be honest. So I guess on most errors, we're gonna say, okay, like this connection's fucking foobarred. We're just gonna like drop it. So could you like kill us? We're done. Unless it's wood blocked. Otherwise, we just return none. Yeah. Yeah. Which makes all this really straightforward here. And then we can do our like we can handle like sending the response failure here as well, like the error 500 or whatever. No field name poll, right? Because I guess this actually needs to be called like a function, like it is. Okay. Empty reply from server. Did I try? I didn't write anything at all. So here we went through read, body, write. Oh, here we de-initted. So here we should probably log the error at least. Error E. Sorry, any. And we'll write down E here. We don't need a new line on std logs. Let's at least see what it is. So we got unsupported. Okay, where do we see that? Unsupported. Oh, because the content length was null. Shit. We log the header here, so let's see what we get. Content type null, content length null. Oh, so I guess in this case, if they're both null. Oh, sorry. Where's the like transfer coding? Oh, here. If transfer coding is none. Ah, I see. So we're actually supposed to switch on transfer encoding, probably. Yes. So here we want to do something like if self header transfer encoding is equal to chunked. This is when we return not supported. Then, if this is null, chunked, if this is null, we just immediately change state and return. Otherwise, we have to actually like get some data. That seems more reasonable to me. No, probably there's no C in chunked. It's probably CHUNK. It did look funny, I just couldn't quite place why. Okay, so now we are getting like spam pulled, which is interesting. Very interesting. I would kind of because here we should immediately say return self state finished. There we go. So if we do that, then we should end up we should close the connection automatically, and curl should say that we got an empty reply. Perfect. Okay, we're kind of getting somewhere. We're definitely getting somewhere. So now on write, I guess we are going to maybe load some resource to send back. 5 adverts, yeah. Sorry, I guess you won't even see it. 3-minute ad makes for no pre-rolls for the next hour, which is huge but annoying. Yeah. Anyways, let's see. So here we're gonna have to have some sort of response. So let's for now just hard code something. So we'll just say, you know, doc type, is it exclamation mark doc type? HTML? Head, body, hello, smiley face, and then here we could say like title and example HTTP server. And then here we can just try to write that response. So here I guess we should keep track of like response written. That seems reasonable-ish to me. And I guess we're kind of in this, by the way. This is sometime before an hour. We start working on sending HTTP response. I just don't know when that was. Okay, so here we keep track of how much we've written, and we, in the write state, basically just say like self TCP write response from response written onwards. Is there, this can fail in some way? And this has to be self-response. No, just response. And this gets response written gets incremented. This has to happen in a loop in case there's like this fails for whatever reason. Like sometimes this this doesn't write all that you want to write, but it also doesn't mean that there's not more available for writing. So we have to be careful here. So here we're going to say this. If it would block, it's okay. We'll just bubble up and we'll call it again later. But if self-response written is equal to response len, greater than or equal to, I guess, technically, we will say self state is equal to finished and return. Otherwise, we'll fail out with an error would block. And honestly, we might be chilling. Curl. Received HTTP 0910. Oh, right, because I can't just fucking blindly write the body like a dumbass. We actually want probably two states here. We probably want write header and write body, right? Writing this write thing is write body, which is write body here. But we also need write header. This is write header. And here, this, when we finish reading the body, we go to state write body, not write. Or sorry, write header, not write. Boom, boom. No function write header, so we can just fix that real quick. And what do we do in the write header section? So we're gonna have to make a header for writing, which I guess we will just stash here like everything else. So header buff is going to be some sort of, I don't know, something. Do I write ampersand here? And this isn't usize, sorry, u8. And zig build. That's fine so far. What goes in this thing? So I think that we can probably leverage the standard library again here. We can probably be like function prepare. I guess the header is probably fixed, to be honest, for now. So we're gonna have like std HTTP server response. Like what happens here when we write ourselves? There's like respond streaming and just respond, I think. Yeah, here. So here they respond with a respond options, and the respond options has this stuff, which doesn't have like automatic serialization. But it does have like a version and status and reason. So how do they use this thing? When they call respond, do they have any... Oh, they just fucking like, they just run it, huh? They just run it. Okay. So I guess we will just write our own header response. I guess that's fine. So let's maybe start with. Let's run our existing thing, and we can just kind of like curl the verbose index HTML, and we'll just kind of. Oh, there's like nothing in here. Okay. Okay. Simple. Simple. So our response is literally just this is how you write code, right? You just cut this shit here. There we go. And then we just have to make sure that all of our ends are /r/n. So I think we can just do this. These guys don't need it, right? It's only this stuff that needs it. But I think that should be fine. Which means that our right head response, right header, and right body actually is not an important distinction. But it will be later, so I'm just going to leave that in there and just say we immediately go to the right body, so the right body state for now. Zig. Multi-line strings don't escape. Fuck. No, really? That sucks. Oops. Am I running the wrong thing? I sure am. Empty event loop test. So here you're telling me that if I run this, I'm gonna get yeah, that's pretty funny. Okay, so does that really mean that I have to? Is there like string concatenation in this language? Like in C you can just write two things next to each other, plus plus. Yeah, that sounds right. Yeah, so we'll do like this, I guess. So this turns into a quote. We get /n quote space plus plus here. There we go. Simple. Yeah. Sure, let's try that. Curl? Fuck. Chunk, hex length, character. Oh, because I wrote chunked. Right. So this actually has to be, we need like content length, huh? You could still do the body as multi-line. That is also true. That is also true. So what does like a normal like content length thing look like? Curl dash v this. What does that look like? Dude, holy, that's a lot of text. Content length here. So it's just content length colon, and then do they have transfer encoding on here? Let's just kind of copy this. Paste this and look for transfer. So no transfer encoding, just content length. Got it. Got it. I know that said HTTP2, but I'm assuming that it's close enough that I don't have to worry about it. So here we just write content length. And here we're going to need to basically figure out this content length. But we'll just start by writing 100 and come back for it in a sec. Curl. Oopsies. Curl. I don't want to curl Wikipedia. I want to curl my shit. Oh, nice. With 6 bytes remaining to read. So we can actually just change this to 94 here. Because curl kind of just told us how we fucked it up. But yeah, not bad. So we got a response back, right? and it looks like not that shit. It says connection to localhost left intact. I'd be curious to see if if we are correctly de-editing ourselves anyway. So here I'm just gonna say console log. Fuck. I've like literally like never wrote JavaScript like outside of like a couple times on stream, and I'm still like got like the console log bug stuck in my fucking head, man. Like it's like my least used language. Why am I doing this? Sick. Okay, so what happens is then curl closes the connection, and we notice that and DNA'd ourselves. So it looks like that's actually all kind of like working out, which is pretty sick. And I would like to say, I'd like to point out that like this is kind of why, like the more I write like iterators and state machines and stuff, the more I kind of feel like there's no reason for async syntax in the language, right? Like the concept of being like, hey, this guy's gonna call into us and we're going to be in some state and we're gonna do some action based off that state. Like, is this really that much worse than writing await a few times and doing it like with an imperative style? I don't really think so, right? This isn't like that bad, to be honest. So I'm actually like very okay with this. Yeah, feels good. Feels good. We have to handle error here. We have to like there's a couple other things we have to handle, but like just the concept of like running a state machine is like I don't know. I feel like I should have gotten comfortable with this way earlier in my career. Okay, so this response thing is going to have to be kind of like injected, right? We're at the very least going to have to inject our content length here. As far as I know, the async await stuff gets compiled in state machine. Yeah, exactly. It does. It does. Yeah. Well, I mean, I shouldn't say it does like concretely with C#, but like I at the very least I know that the Rust stuff it does, right? Because like it's the only way for where it makes sense, right? You at every await point you just inject a new state, or every yield point I should say you just inject a new state, and then you're good to go. Right? It's like, and often you have to like in Rust, you end up having to write those sometimes anyways. So it's like you I guess like you have the benefit of being able to build up primitives, right? You can then build up your like low level state machine stuff and then compose them nicely with async await, but I just don't know if it's worth it. Sometimes being able to yield from a generate function is nice, but you can always just save yourself the state you care about and restore the state manually when you want to resume. Yeah, exactly. You could turn your response into a format string and use counting writer plus print to get the content length. Oh, that's interesting. Turn response into a format string. Use counting writer plus print to get the content length. What is counting writer? Learn. Standard library docs. What is this thing? So if this like counts how many bytes were written, I can't get the content length out until I've already done the write, right? So I think that doesn't make sense. I think what makes more sense is for us to say response header here gets a number input here, and then we say const response body is equal to this. And then this stuff we can go back to the other way of doing it where we had this and boom, 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 boom. We want to delete those backslash n's as well, actually. So boom, 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 boom. And then we should be able to just be like, here we're going to like have a response buffer. So response is const u8, and we're gonna write in this one time. So here, when we finish reading the body before we go into the, I guess technically we know this ahead of time, but like let's assume that we're going to be switching this out later, right? So here we can basically say like when we are trying to write our header, let's think about this. Let's think about this. So I guess we actually only want the response header here, response written, and then we'll have body written as well. Yeah. That's starting to make sense. That feels like it's making sense to me. So in the right header state, here we're gonna say if self response header len is equal to 0, we are going to generate it. So self, std format alloc print. We're basically gonna say we're alloc printing with some allocator. We are printing the response header, but with the parameter of response body len. Do you actually need the content length in the response if you close the stream right after? I kind of assumed you did, and also I wasn't planning on closing the response right after. I was planning on leaving it open as like an optimization because we can do that now. Before we were closing the socket every time because we literally couldn't do anything else without like just hanging our server. But now we could leave connections open. I don't see any reason to not do that, right? Like if we're polling 120 times per second, those reuse connections are actually going to have like meaningful savings, I think. Could be wrong though. So self response header is this. And again, we just do a little bit of this shit, but instead of us doing response written, this is a, I guess this is response written. I guess we kind of need another, this will be header written and body written. We'll just track those separately. Header written, this is self response header, header written, response header, header written. There we go. And this state goes to right body. There we go. And then this is now everything in here is body related. So body written. This probably can get factored out in some way as well. But fuck it. Okay. A little bit still missing. So 170 we have body written, not response written. Okay, and this curl still work? Yep, okay. Chilling. Okay, so now maybe we can try to change this so that we can like do some form of like JavaScript. Like maybe at the very least, let's write like the world's simplest website, where we have a website that has a number that increments for every request, and we will send a request once a second. That way we can kind of like flush out the API of the whole server, and then integrating later will be easier. So let's do, or at the very least, I think that it's likely that by the end of this stream, I won't be in a state where I'm like ready to integrate with Ball Machine. But if we get to the point where we have an interactive server that can do everything we need to do with a shitty little demo website, then I can do this off stream because I don't think that this part is really that important. So that's kind of why I'm doing it this way. So here we're gonna say like world's simplest interactive website. Right? So here we're gonna have index HTML, which means that everywhere we had response body, we're gonna have to replace with index HTML for now. In here, maybe let's add like a second file, and we'll call this index.js. And this guy's gonna have, some shit. Async function init. And I guess we're gonna call this like tick. We're gonna say window onload equal tick. Here we're gonna say window set timeout 1000 tick, I think. I don't really remember my JavaScript, and the lack of syntax highlighting is not gonna help me. But then we're just gonna say let blob is equal to fetch counter, right? This is blob response, if I remember correctly. This is await, and then we get a response is await blob response JSON. So this gets the head, this gets the body. And then we should be able to do something like in here we have div id is equal to count. This starts at 0, and then we just say document get element by id count inner HTML equal response dot count. Okay, so we're gonna make like a little. This is gonna give us something that's like, count 0, right? That's what we're basically trying to send up here, based off of whatever they send. And so we are going to need to have like 3 endpoints here: index.js, index.html, and counter. But maybe we'll just start with one of them. So maybe we say, maybe we're gonna change this a little bit. Instead of this generating the header here, maybe we'll do something like set up response. Right? response. I also want to be clear here. You're kind of seeing me like kind of stash all of this stuff at once. There's a chance that I'm gonna go off stream later and like turn this into a state machine with a union and enum tag, right? Like I think that I'm not really clear all the time that what happens on this stream is very much like what I would consider like prototype phase of something, right? Where you get kind of like a lot done rapidly while you're experimenting with a new concept, trying to figure out where does this code go, how should this be set up, blah 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 blah. But then you have like this like extra section after where you're like, okay, so now that I know what I want to do, like let's pretty it up a little bit and make it so that if somebody were to review this, they wouldn't be like, what the fuck have you been doing? And so like there is like off-stream work that gets done to clean that up. But anyway, so that's why right now I'm just kind of storing everything inline, and I probably will undo that later, just for the record. Okay, so here I guess we can maybe say that our body is also going to be a const u8 pointer. And what we'll do is when we set up our response, we can basically just set that to whatever we fucking feel like, right? So we can say self.body is equal to response index HTML. And this won't do a copy. It'll just like it'll just be like take the body pointer and point it to the index pointer. And you'll see in std format alloc_print they write twice. Once with counting writer. Oh, really? Interesting. Do they actually? Oh, that makes a lot of sense because they don't know how much memory it's going to need until they format it. Oh, that's really interesting. I didn't realize that. So the counting writer to a null writer, very interesting. Right, because here they get the size from. Oh, this is alloc_print. Oh, count format args. I see. So in here they use a counting writer to null writer. That's very interesting. That's pretty cool. I didn't know that. Good to know. That should help build intuition around like cost of this type of thing. Right? If you had a very expensive formatter, then you actually wouldn't want to do this, which is pretty interesting. This stuff goes here, and then self state is equal to write header. And then here, every time we used to go to like write header, we're just gonna say self setup response. Boom. So that's here and here. Okay, and then what we should do here is first let's make sure that it still compiles and works the way we expect, because I don't think we actually changed anything. Error union is ignored at 144. So this, that does make sense actually. So this needs to be try, and this needs to be try as well. Okay, and then curl, we're chilling. We still see what we expect to see. And now we can actually like switch behavior here based off of what we see in our head. So we can say switch, URIs, or targets, we'll call them, is an enum that is index.html, index.js, counter, as well as just an empty slash. And we will say self header target. We will basically try to like parse this thing. So we'll say const target is equal to stud meta string to enum of this thing, or else we will return an error of like unsupported, invalid URL or something. I don't care. Not found. That sounds more right. That's what the 404 name usually is. Then we can switch on this target. And depending on what we get, we do something different. So this, these all get dots in front of them. This gets an arrow. This gets an arrow. And this gets an arrow. Okay. So here, if we get index HTML, we do this, what we were doing before. If we do index.js, we get the same thing, except we don't want index HTML. We kind of want this. In fact, maybe we can say that the response header, oh no, the response header will change based off what we get. So we will do it this way, that's fine. So this is index.js.len. And our counter is going to do something completely different. So our JSON response header is going to be the same. It's going to be a text JSON. But the rest I think is the same. So I think this is actually fine. And here we're going to say our body is actually going to be like an allocated thing. So for now, we don't need to go through like any like fancy JSON serialization, to be honest. We can do this. We can say self body is stud format alloc print using self alloc and something. Some format string. So we're going to say count. This needs to be escaped. Is equal to some number. And that's it. And we're just going to pass in count. Application JSON? Really? I believe you. I always forget which ones are applications and which ones are text. It seems like text JavaScript. Oh, right. We actually need to do this for the JavaScript one as well, huh? We need this for JS response header as well. And this one's text JavaScript. It seems so crazy to me because to me it seems like JavaScript is an application and JSON is essentially text, right? JSON doesn't like execute anything. Like these things feel more like applications than this does. But whatever. I'm sure there's a reason for it, and instead of thinking about it, I will just be confused for the rest of my fucking life. And this is going to be self body len. Okay. Now here we have to be careful because the count is actually going to be managed externally. So I guess we'll just make it a global for now. This is not the nicest way to do this, but it's good enough for me. Good enough for me. All right, so that might work. I guess we need to actually use the script from our index.html. I don't think we did that. Script source is equal to index.js. And that might work. Fuck. Unused local content. 185, because when we did our string to enum, we actually have to say which enum we want, or else how the fuck can it know? How the fuck would it ever know, you know? Oh, fuck! No field name count, right, because it's a global, so we'll just call it count. Which means that here we also have to call it count. Out of memory, so this guy has to write try. All right, and let's see what happens if we go here. We're getting error not found for something. So we can actually take a quick peek at which index.js not found. Why? Am I stupid? Request? Can we like maybe look at the raw request headers? Index.js? Index.js? What the fuck? Target is self header target. What the fuck is going on? Oh, is it because when we try to ask for fav econ, it like kills itself? We can maybe. I guess here when we get not found, do we? No, this should be fine. Should be fine. So here we got target fav econ. Where is index.js coming in? Okay, there's too much going on here. No, it should be fine. Let's look again. We're gonna look very carefully. So here he's getting spam pulled. I don't know what the fuck is going on here. Here we finally get something, and we say we found index.html, we found index.js, we're chilling. We found then he gets a bunch of fav econs that are not found. So here I'm surprised that it says that we got a partial transfer here. Oh, we fucking sent the wrong thing back. Is it because when we write body, we have index.html hardcoded? We do. Fuck me. So this should be self body here. Self body. There we go. Little buggy. Okay, so now we got our index.js. And can we unexpected token identifier? Okay, so here we must have just like fucked up our JavaScript. Probably fn is not right here. It's probably function. Okay. Okay, so this only ran once. Oh, is timeout? Like, what unit is timeout? Window set timeout. I thought that this lets me call a function after some amount of time, but I could be wrong. Oh, it's the other way around. Fucking JavaScript, man. The fact that there's no errors when I just fucking don't even give it, like, write 1,000 in the location the function pointer is supposed to go is fucking insane to me. What a fucking dog shit language, man. I guess it's really more the interpreter that I'm mad at the language, but they're kind of like equivalent. Okay. I'll fucking take it, man. That's so sick. Look at that. That's so sick. And then I guess, like, is this reusing the same connection? This is de-initting over and over again. Do I have to specify if I want keep alive? I want to see if I can reuse the same connection. Okay, let's actually maybe, can we, I want to get rid of some of these prints. And I want to see if we can, like, see if we're reusing a connection. Oh, we're definitely not reusing a connection because we don't ever do any resetting here. Because when we get to finish, we immediately de-init anyways. So they couldn't even reuse the connection if they tried. But it would be nice to try to get that working. So we can just say we're at like 0134. And let's try to do like connection reuse. I'd be kind of curious if we can get that working. Okay, let's get add-u, get commit-m, HTTP, async, checkpoint. Do I have a limit on the connections? No, and I probably should. But for now, we we just wrote this 3 seconds ago, so we haven't really got there yet. Okay, so what do we want to do here if we want to try reusing a connection? Here's just that instead of d-init, we just reset ourselves, right? So we kind of just take all of this stuff. and reset whatever is relevant. So TCP, the allocator is fine. That stays how it is. The TCP connection, that stays the same as well. But our state becomes read header, like it was at the beginning. Our header parser has to be reset as well. We need to free our buffer. And then reset it. Our header is equal to null. Our header size. I think all of this stuff kind of gets basically as it was on initialization. And honestly, you know what probably makes more sense than doing it like this? What makes more sense is if we did self is equal to, and we kept the stuff that we care about. That makes way more sense. That way we don't have all this stuff duplicated. And we just reset by saying self.tcp is equal to self.tcp, and then everything else just goes back to the way it was at the beginning. Oh, I see. So you're saying, yeah, I don't know Zig, but I was wondering if you need to account for either the client or the server, limiting the number of simultaneous connections. That's a reasonable thing to think about. But I think that in our case, it was just that we were like explicitly deinitializing ourselves every time we finished answering one request. Which child of your children do you like more, Rust or Zig? I think that at this point, I'm having much more fun writing Zig. I don't know if that's just because it's new. I don't know if that's because it's better. There are things about it that I definitely like that make it more viable to me than writing C, which I like. It feels like way more reasonable to write than C++, which I also like. If I'm comparing it to Rust, the comparison gets a little trickier because now all of a sudden, my like what I'm doing matters a lot more, right? I think that if I were to like, if somebody just contracted me to make something, I'd probably write it in Rust, right? Because probably if somebody's paying me to write software, the ability for me to just like bang something out where once it compiles, I have like reasonably high confidence that it will work for a long time is like very, very important to me. Where when I'm like prototyping something for myself, the flexibility that like Zig provides me feels more important. Like for something like this, I don't really care if I'm seg faulting because I make a mistake, right? And maybe that's like I shouldn't maybe be advertising like, well, I think in Zig I'm gonna have seg faults because I don't really know if I think that. But like the idea, there's something about Rust where I still believe that the like bulletproof abstractions that you end up with by writing it like results in something that is nicer in some ways. It's just worse when you're writing, which, well, in some ways, right? As we saw last stream, sometimes a small mistake can cost you an hour, which really fucking sucks. So, but if the frequency of those mistakes is lower than the savings of, or is lower than the cost of writing Rust, which I mean, the cost of writing Rust does exist, right? Like it just totally depends. I think that probably if I started a company, which I would never do because I don't want that fucking type of responsibility. But if I were to start a company, and I were going to hire junior developers, which every company will, then I think that I would prefer writing Rust than Zig because like the idea of like in Zig, like the concept of abstraction is like a lot different, right? You can't have private fields in Zig, which is like great if you're a hacker. It's shit if you're trying to protect yourself from a junior developer who doesn't know that they shouldn't do something, right? Which is like, I'm not saying like shitting on junior developers. I'm just saying like when I was a junior, there was all sorts of stuff that I would try to do that I shouldn't have. And like, then you just have to like look for those things in review. It's just like so much more work. And so like the idea of like, okay, I wrote this class and I know that anybody who uses it, if they use it wrong, it's my fault. There's like something nice about that, you know? So I don't know. Hard question to answer. I mean, if you're asking which language I prefer using for myself, Zig at this point in time. But that's like a big, like a enjoy is not necessarily the same, you know? If you're asking which to use first, the answer is you should have both in your toolbox eventually. I don't know if I agree with that. I think pick one is fine. I think both are fine choices. I don't know if you will ever need all things in your tool belt, right? I've never written Java. I'm sure that I could pick it up, but like saying that like I should have it in my toolbox. It's like, well, it hasn't come up yet. You know? What was I doing? Connection reuse. So how do I tell what's happening here? I guess we should print on new connection. So here, we'll just say function std debug print new connection. And then everywhere we're not, and then we will maybe log on each finish. Yes. And so here we'll say std debug print finished. And we will see if these do not, or if these are different. If we see like 1-to-1, then it's bad. But it looks like, oh, hell yeah. Look, that's actually already kind of working, right? So we have one new connection here, and this JavaScript counter is reusing the same HTTP connection over and over and over again, which is fucking sick. That's sick. And then I can open a second instance of this, and these guys run in lockstep, and they're both running at the same time, and they're both getting what they need to get. And these are jumping up by 2 because we're seeing that the counter from both are running at the same time. That's so sick. That's so sick. All right. So there's definitely like things that need to be fixed up here, right? Let's see what those are. So maybe we recap what we've done. So we wrote this like HTTP server, which is essentially like a state machine that sits around a TCP socket. When this epoll or our event loop basically calls this poll function on a socket state change, right? So if it was like idle and now that there's data available to be read, we get called. If it was idle and somebody wrote to us, we run through it, right? What happens now is like we have this like infinite loop. It looks infinite, but it's not, right? Because we say we go through like one state, and then this function will transition us to the next state if there's enough data. But if there's not enough data, our interactions with the socket will throw an error that are like E would block. And so in that case, we go back up to our parent and we say like, hey, epoll, we have no data. Just call us again when we're ready. And so each of these functions is like ready to basically start from scratch again. Like they can be interrupted at the point where they read data, and if you call them again later, they'll just like resume where they left off. When we finish, we read the header. Using Zig standard library. We read the bot, well, somewhat. We use their header parser as well. Yeah, we use their header parser. We read the body, which is just like read all the data that's left. This will have to get capped actually. So did we write that down already? Set reasonable max length. Yeah, so this we'll have to cap this. We then write out a header depending when we finish reading the body, we like decide based off of what header that we got, what type of response we're gonna set, right? So here we have like our response header is one thing. Like if we get index HTML, we send them index HTML. If we get index.js, we send them index.js. Simple. And then we like kind of like set up some state so that when we write out the body and the header that they're like coming from the right spots. Yeah. So pretty sick. I'm pretty happy with that. I think that there's some allocations that need to be cleaned up here. I think that it's likely that I will want to kind of collapse this state so that into like an error, like a union of some type, so that basically like only the parts that are relevant in each part are available, right? Like the fact that like this header is null and like we then expect it not to be null in some states, like we could like represent that with the type system a little better. We got like connection reuse working, which is pretty fucking sick, and we can now service multiple connections from one thread. Very fucking cool, very cool. Pretty happy with that. So I think I'm gonna call it there. A little bit of a shorter one today, you know, an hour 45 instead of plus 2 hours, but we can live with that. If you like what you saw, guys, I stream most days at around 2 o'clock Pacific time for around 2 hours. So if you're live, that would be anywhere from 2 hours ago to now-ish, right? If you're watching on YouTube, you'll have to figure out when Pacific time is for you. If you're watching on Twitch, there's a YouTube link on the in the Twitch description where all of our previous projects are organized into playlists. Right now, we didn't really touch on it too much, but we're working on this like collaborative Rube Goldberg machine. So the idea is that we're writing this web service that runs some physics simulations on some balls, and the environment that the balls are in are defined by WebAssembly modules, both like the rendering of those things as well as the physics of those things. So that's what we're working on, and we'll be probably back at that tomorrow. I think tomorrow's task is to get login working. So when you guys upload chambers, you're going to want to I'm going to want to tie those to your Twitch usernames, right? Assuming that any of you ever do it, right? Who knows if that's actually going to happen, right? But then, like, when we see a chamber, we can, like, show on it, like, we can put in the corner of the chamber, like, by whatever Twitch name. And then also, if you're fucking weird, I can ban you in my chat if you, like, draw a dick on me or something, right? So, which is kind of nice. So that's the task for tomorrow is, like, log into the website with Twitch and then maybe some sort of, like, chamber upload. But we'll see how far we get. Yeah, if you're watching on YouTube, there should be a Twitch link in the YouTube description. Like, subscribe, Twitch Prime. Yeah, that's it. Buy YouTube and then Twitch. Let's send you over to someone else.